Okay, let's do a question on demand. As with all these videos, we're going to read through the question. I'm going to point out how I'm parsing the information in the question and explain any choices I'm making as we go about solving the question. So let's get to it. All right. Daphne's utility from consuming bagels and cream cheese is given by the following function. U of B and C is equal to 12, B to the 2/3, C to the 2/3. So it seems we've got ourselves a nice Cobb-Douglas utility function here. B is the number of bagel sheets, C is the number of packages of cream cheese. Okay, so B and C are two goods. Part A, derive expressions from the margin utility of bagels, MUB, and the margin utility of cream cheese, MUC. Explain whether these functions seem realistic for someone who enjoys both bagels and cream cheese. Your explanation should address the sign of the margin utilities and how the margin utilities change as both B and C change. This explanation should be specific to bagels and cream cheese, not just two generic goods. All right, we'll get back to that explanation stuff in a second. Let's start by just getting these margin utilities to begin with. So my margin utility for bagels is going to be the derivative utility with respect to B. All right, so I'm looking up at my function here, bringing down my exponent. My 12 out front stays the same. I'm lowering my exponent on B by 1, so it becomes B to the minus 1/3. And I'm leaving my C to the 2/3 as is. So you could leave it like that if you wanted to in the exam. I don't expect you to simplify, but to me, this simplifies somewhat nicely. So this 3 would simplify with that 12 to leave us with a 4. So that's going to be 8. And then that's going to be C to the 2/3 over B to the 1/3. Right? To me, that's just easier to look at, easier to interpret. Go ahead and get the margin utility for cream cheese as well. It's derivative utility with respect to C. So it's actually going to look pretty much the same because we've got C to the 2/3. So I'm going to bring down that 2/3. Still have the 12 out front. The B to the 2/3 stays as is. We've got C to the minus 1/3 now when we lower that exponent by 1. And so that thing's going to simplify to 8 B to the 2/3 over C to the 1/3. All right, so we've got our margin utilities. Now back to what the question was asking in terms of our explanations. Do these functions seem realistic for someone who enjoys both bagels and cream cheese? So first things first, both are positive, right? So I'm going to go ahead and say yes, both are positive, right? So it wouldn't make sense if they enjoy bagels and cream cheese but have negative margin utility from them. Okay. I'll say meaning they enjoy both. All right. So that addresses the sign, but now also how they change as B and C change. Okay. All right. So notice that for margin utility of bagels, as I eat more bagels, B's in the denominator here, MUB is getting smaller, right? So we've got diminishing margin utility of bagels. For C, it's the same thing, diminishing margin utility of cream cheese, okay? So in both cases, diminishing margin utility, right? And I'm going to say that makes sense, right? So both exhibit diminishing MU. I'm going to say that makes sense because when you're really hungry, an extra bagel and cream cheese is really enjoyable. As you get full, won't like an extra one nearly as much. So, pretty reasonable explanation there. The one thing that I wanted to make certain I did is paid attention to that last sentence up here that said your explanation should be specific to bagels and cream cheese, not just two generic goods. So I can't just say that diminishing margin utility makes sense, right? I've got to make it something about food here, right? So something about being hungry versus being full. Right? That's what's going to get me full credit on that question. All right, moving on to part B. Derive Daphne's demand for bagels in terms of the price of a bagel, the price of a cream cheese package, and Daphne's income. So PB, PC, and I. It's just a standard derived demand question here. So we're going to take our pretty standard approach to this. We are going to start with our tangency condition, which is going to be that the ratio of the prices, so PB over PC, should be equal to the ratio of the margin utilities, MUB over MUC. So now MUB over MUC, we found expressions for those up here, right? So that's going to be 8C to the 2/3 over B to the 1/3 divided by 8B to the 2/3 over C to the 1/3. Those 8s are going to cancel. And all this, as usual with our Cobb-Douglas function, simplifies quite nicely. This is going to be just C over B, right? Okay, I'm going to move this B over to the other side to get C by itself. That's going to give me C equal to PB over PC times B. So now that I've got that, right, that's as far as I can go with my tangency condition. I can plug that into my budget constraint, right, to get rid of C in that equation and then solve for B, right? So PBB plus PC, and now I'm replacing C in my budget constraint with this. So PB over PC times B, all of that should be equal to my income. All right, so this PC cancels that PC. I'm left with PBB plus PBB is equal to income. So let's move that up here, give myself a little more room. That's 2PBB is equal to I. And so my final expression here is that B is equal to I divided 2PB. So let's go back up to the statement of the question, make certain we got what we needed. It said Daphne's demand for bagels in terms of the price of a bagel, the price of a cream cheese package, and income. So PB, PC, and I. So looking down here, I've got I, I've got PB, I've got a 2 in there, I've got nothing else. So we're good, right? If I had PC in there, that would also be fine. What I don't want to see is, say, like a C still floating around in there. So that is my final expression. Part B is done. Okay. All right. So now we're ready to move on to part C. So what is part C asking us? Graph Daphne's demand curve with price of bagels on the vertical axis and number of bagels on the horizontal axis. On a separate graph, graph Daphne's demand for bagels resulting from varying the price of cream cheese. So a graph with PC on the vertical axis and B on the horizontal axis. Okay, so I have run out of space here. So let's go ahead and grab another sheet of paper to do this on. Okay. So this would be like moving to the back of your sheet of paper. What I'm going to do though is I'm going to transfer my demand equation to the back so that I don't have to keep flipping back and forth. So I just found that B was equal to I divided by 2PB. Right. Okay, so the two graphs that I'm being asked to do in part C are one graph with B on the horizontal and PB on the vertical, one graph with B on the horizontal and PC on the vertical. All right. Okay, so I'm focusing on this demand equation, and on this first graph, right, B is inversely related to PB. So this is not a nice simple line. There's no intercepts here, right? So as PB gets close to 0, B goes up to infinity. As PB gets close to infinity or goes to infinity, B gets close to 0. So it's just going to be one of these shapes. There's really nothing more I can do with it than that. Okay? But fortunately, that's all I have to do with it. All right. For this one, well, there's no PC in here, right? So what am I actually graphing? There's still something to graph, right? There's still a value for B. It's just whatever this number happens to be. So somewhere on this horizontal axis is the value I divided by 2PB. And so no matter what the value of PC is, that is simply what B will be, right? All right, so that was our part C. Our final part is part D here. So part D is asking us to graph Daphne's angle curve and to label the slope of the angle curve with its value. Note that your slope may contain prices in addition to numerical constants. Okay, so angle curve, we've got to remember what that is. The angle curve has quantity on the horizontal axis and it has income on the vertical axis. All right. And so if I look at my demand equation here, when income is 0, quantity is 0. Right? So my angle curve starts here. And then B is linearly related to I. So it's just going to be a straight line. But now I need to know the slope. All right? Here's where I want to be careful. I have B on the horizontal, I on the vertical. So I'm going to take this equation and just rewrite it to have I on the left-hand side, which would be I is equal to 2PBB, right? Now this is written like the equation for a line on this graph, and so that coefficient out front is my slope. So my slope is 2PB, all right? If we were given a value for the price of B, I could plug that in and give an exact value for that slope, but we're not, so I can't, all right? And so that's our problem.